Today I'm going to make you a math genius. You are going to learn how to multiply and divide polynomials. Now we're going to start kind of simply. We're going to begin with multiplying a monomial times a binomial. If you take a look at this, guess what? You have always been doing this. This is just the distributive property. So don't do anything different than what you've done before. So if I have this, remember it's the outside number times the first. You keep that addition the same and the outside number times the second. So you can see I have negative 2x times 3x squared plus negative 2x times x. Now the only difference here is we have to start to use some of our exponent rules when we multiply. So again, we start with our coefficients. If I have a negative 2, I multiply it by the 3. So the coefficient is multiplied by the coefficient. And so I get negative 6. But now I have an x times an x squared. And when you multiply variables that have exponents, you actually add the exponents if those variables are the same. So because I have my x and I just have one of them and I'm multiplying by an x squared, I have to add those exponents together. So in the end, I would get negative 6x cubed. That's the only difference of what we're doing differently than what we did before. So now we have to do the same thing on this side. Now here's my coefficient of negative 2. I don't have a coefficient in there, so I don't multiply it by anything really. It'd be like there's a 1 there, and I know that negative 2 times 1 is just negative 2. But I have a single x there, and I have another x there. So I'm multiplying those variables together. Therefore, I have to add those exponents. 1 plus 1, I get negative 2x squared. Now, remember, these are two different terms, and I cannot pull those x's together because this has a degree of 3 and this has a degree of 2. So they have to remain separate. So in the end, I would rewrite my final answer as negative 6x cubed, change that plus back to a minus, change that negative back to a positive, 2x squared. So nothing different, we're just applying what you've learned before. Now we can also do that with a different polynomial. What if we had a monomial times a trinomial? Well, trinomial just means there's 3 terms, but notice it's still the distributive property. Now I put my monomial at the end, so remember that monomial can either come at the front or it can come at the end. Now I made it a little more complicated because I made sure I put those subtraction problems in. And we know that subtraction is the harder operation to work with when we have integers. So again, like we've always done, we're going to change that subtraction to plus the opposite. It's the first thing I do all the time when I'm going to go solve these. So first I rewrite my problem. So I get 5rs plus a negative 2r plus a negative s squared, and that's a negative sign there. Once I've rewritten it, now we go back to that distributive property, but we're just going to do it 3 times. So I'm going to take negative rs and multiply it by 5rs, and you can see it there. Now it looks complicated because there's lots of variables there, but always rely on just the basics that you've learned. And I'm going to do negative rs times negative 2r, and I'm going to do negative rs times negative s squared. So now we're going to have to pull this together, and we're watching our integer signs and we're watching what happens with our variables. So here's the complication. Again, I have no coefficient, it looks like. That means it's a negative 1. So I'm going to do this negative 1 coefficient times this 5. That's where I get my negative 5. Now my r's can only go together with my r's. My s's can only go together with my s's, but I separate them in order to pull together those exponents. So I'm going to do my r and my r. Now notice I have 1r there and I have 1r there. I've already taken care of that negative sign, so don't worry about it. It's already there. So it's really about r times r. Well, r times r is r squared. And then I only focus on the s's. S times s, well, I have 2 of them, so I add those exponents, I get s squared. So that term becomes negative 5r squared s squared. So you always keep those variables separate. So let's go to the second set of terms. So here I have a negative 1 times a negative 2. And I know a negative times a negative is a positive, so that's where I'm getting my positive 2. And then I'm done with those negatives. So now I'm doing my r times my r. Well, I have one r there, and I have one r there. Therefore, in the end, I'm going to have 2 r's, or r squared. Now, notice there's no s on this one, so I just have that single s, so I bring that s down. So there's my second set of terms. So now I'm going to go to my last one. Again, my coefficient would be a negative 1 times a coefficient of a negative 1. And we know a negative times a negative is a positive. It's a positive 1, so I'm just not going to write that coefficient. So I have an r, but there's no r here. So there's nothing I can multiply it by. So I'm just going to leave it as r. And then I have an s times an s squared. Well, I have one s there, and I have two s's there. So therefore, I have to add those two exponents together, so I get s cubed. Now, lots of kids want to try to pull these terms together, but they're not the same terms, because this is an r squared s squared, and I don't see any other r squared s squareds, so that has to remain by itself. And this is an r squared s, and I don't see any other r squares s's, so that has to remain as a single term. And this is an rs cubed, and there's no other rs cubes, so that has to remain by itself. So in the end, this would be my final answer that I would have to leave it at. We cannot pull it together, even though you see those similar variables there. So it looks impressive. This is where your math genius comes in. Now, if we were given a division problem, typically how it's going to look like is you're going to have a polynomial on top, and in this instance I have a trinomial on top, and you're typically going to have a monomial on bottom. Now, my first step is I always rewrite that division problem, and so I take each of the individual terms of the trinomial and I separate them out by themselves, and then I'll take that monomial on the bottom and I put it under each one, because it's being divided in each of those terms. This makes it easier for me to see what's happening. Now, once we do that, now we just apply what we know about dividing exponents. So when we divide an exponent, if we take this first one, we have 11m8 divided by m squared. So when we go, let's add that m back in. The 11 has nothing to be divided by. There's a 1 as a coefficient, so we're working with those coefficients again. So 11 divided by 1 is just 11. That stays by itself. Now, when we divide variables that have exponents, remember we subtract those exponents. So this becomes m to the 8th power minus 2. That's where I'm getting my 8 minus 2. So in the end, if I went and I actually combine those as my division, I get 11m to the 6th power. Notice now we don't have a division sign anymore. Then I'll move on to the next term, and I just keep that subtraction sign in there. I don't have to worry about it. So again, now I have m to the 6th divided by m squared. So by rules of math, because that variable or that base is the same, I just subtract those exponents. So I do 6 minus 2, therefore I get m to the 4th power. And then I'll go to my last term, but I keep that subtraction sign the same. 2 divided by 1, because I'm only dividing my coefficients, would be 2. Then I get my m squared minus 2, because you're subtracting those exponents. Well, here I then get 2m to the 0 power, and we've learned that any number to the 0 power always equals 1. Therefore, that m to the 0 power disappears. I just replace it with 1, and now I'm going to pull it all together. So 11m to the 6 remains, minus m to the 4 remains, and then negative 2 times 1 is negative 2. And I can't pull anything together because I don't have any other m's to the 6's. I don't have any other m to the 4's. You can only pull together like variables with the same exponent. So I think you can see you just became a math genius. I hope you go and impress your parents, your grandparents, anyone you know with your knowledge. Good luck. Have fun.